Friends, today we start with terms related to motion, terms like displacement, distance, speed, velocity. These terms can be clubbed under one heading, uniform motion. In uniform motion, we will first define the term distance. When a body is at rest, distance travelled we will denote distance by d. Distance travelled is 0. The definition of distance is it is the length of the path or the track travelled by a body in a given time. It is the magnitude, the length. So, distance has only magnitude. When we say how much distance a body has travelled, we mention only the number of meters. So, meter is a unit of distance travelled. Other units are kilometer, smaller kilometer is a bigger unit, and centimeter. Centimeter is a smaller unit. If we talk about the systems of units, meter is a unit of SI system or MKS system. Centimeter is under CGS system. Now, another term that is related to the path covered or travelled by a body is displacement. We will define first what is displacement and then compare it with distance. Displacement, it is the change in position of a body with respect to it is the change in the position of a body from initial to final position. Here we have refer to initial position and final position. In displacement, we refer to initial and final positions. In distance travelled, we did not mention anything about initial position or the final position. Displacement for a body at rest also is 0. If a body is at rest, displacement is also 0 like distance. But once the body has started moving, displacement can be positive if the body is moving towards the right. From we refer with respect to an origin. If the motion is towards the left, displacement is negative. So, displacement can be positive, negative or 0 even during motion, whereas distance, when we talked about distance, distance is 0 only for a body at rest. Once the body has started moving, displacement is never at rest, distance is never equal to 0. Now, here if we have an object, initially it was at position A, it moves to position B, that is say 10 meters from A, it moves in the same straight line to position C, that is 15 meters. Then again we move to position D in the same straight line, that is let us say 10 meters again. Distance travelled D is 10 plus 15 plus 10, 35 meter. What about displacement? Displacement is magnitude of displacement is also 35 meters, but description of displacement is not complete till we add a direction from initial to final position. In this case, we have moved from A to D. From A to D. Let us take another example. This was the case when motion is in the same straight line in the same direction. In the second case, let us, instead of moving towards D 10 meters, from C we move backwards 10 meters backwards, D is here. Now, distance travelled is again 35 meters. We have moved 10 meters A to B, AB is 10 meter, BC is 10 meter, BC is 15 meter, CD is 10 meters. Total distance travelled is 35 meter again. Now, if we talk about displacement, now displacement is from A to D. This distance will be subtracted from the distance from A to C, 25 meter minus 10 meter. So, this distance magnitude of displacement in this case is 15 from A to D. So, now the we have displacement is from A to D. D is a point that is 15 meter away from D. So, in this case, magnitude of displacement is less than the magnitude of less than the distance travelled. Another example, we have point A to B 10 meter away. We move at right angle to C 15 meter and again at right angle 10 meter to D. Now, the distance travelled is same 35 meters. D is again 35 meter. Now, what is the displacement? Displacement is from initial to final position. This is displacement. Displacement is AD. Magnitude of AD is 15 meters. This is 15 meter and direction from A to D. One thing more, direction, if we are talking about displacement A to D, it is not equal to displacement D to A. So, in displacement, direction is a very important component. Such quantities that have magnitude, such quantities cannot be described completely with magnitude only. We have to add to it. And other thing, direction, such quantities that need magnitude and direction to describe them are called vectors. Distance is a scalar because we needed only magnitude. So, distance is a scalar. Displacement is a vector. Now, another example, we have say A, B, C, and back to A. We move from A, we move distance AB, we move distance BC, we move distance CA, 10 meters, let us say this is 15 meters, 10 meters again. Total distance travelled will be 35 meters. Now, what will be the displacement? Displacement is, we have moved from A to B, B to C and back to A. So, displacement is shown by A vector. Here initial and final positions are same. So, magnitude of the displacement is 0. We will see this later on, this is called a 0 vector. So, displacement of a path which ends in which initial and final position are same is a 0 vector. And other example for this that distinguishes between distance and displacement is a semicircular path. Suppose we have 1 kilometer radius for this path, we move from point A to another point diametrically opposite AB. Distance, we follow this path C, A, C, B, semicircular path. Distance travelled in this case is pi r. R is 1 kilometer. So, this is 3.14 kilometer. Now, what is displacement? Displacement is equal to 2 kilometer magnitude from A to B. So, we have AB is the displacement, whereas distance travelled is ACB. So, we can see if the path is a straight line in the same direction, distance and magnitude of displacement are same. Now, otherwise distance is always greater than the magnitude of displacement. Displacement is a vector, distance is a scalar. Now, suppose instead of this path, we had followed this path ADB, even then displacement will be same. So, that means displacement is independent of the path followed by the particle. It is the straight line distance, magnitude of displacement is equal to the magnitude of straight line distance between initial and final positions, and is directed from initial towards the final position. So, these are the examples that distinguish between displacement and distance. Now, when we say a body is moving, this is body A, there is another body B. Which one of them is running faster? What is the quantity that will tell us which one of them is running faster? That quantity is speed. Speed we define as it is the time rate of covering a distance. Mathematically, we can define speed equal to distance travelled divided by time taken. If a body, this speed is the quantity that you see on your speedometer. When you view your speedometer on a running vehicle, it is showing you the speed of the vehicle. Now, distance is measured in meters, time is measured in second. So, unit of speed is meter per second, or we can write it meter second inverse s minus 1. Other units of speed can be kilometer or miles per hour, and maybe centimeters per second also. Now, because distance is a scalar, similarly speed also is a scalar. Speed is a scalar. We do not have to tell the direction of speed. Speed is sufficiently defined if we tell the magnitude of the speed of a body. We do not have to bother about the direction of the speed. Speed of a body is positive or 0. When the body is at rest, speed is 0. Otherwise, once the body has started moving, speed is positive. Another quantity that tells us about the rapidity of the motion is velocity. We define velocity as the time rate of changes in position of a body. Mathematically, velocity is displacement divided by time taken. So, we can say velocity is the rate at which displacement is covered, time rate, displacement covered in 1 second is velocity. Units of velocity are the same as that of speed, meters per second. Now, what is the difference? Difference is here we have a term displacement instead of distance. Displacement is a vector. So, speed is velocity is a vector. To describe completely, this is not sufficient. Time rate of changes in position of a body in a particular direction. Direction also must be mentioned. Now, suppose we have a body moving in a straight line. We take this as origin. At time t, body reaches here. This distance it has travelled distance x1, position of the body, distance between origin and position of the body presently is x1. After time t in time t dash, the same body has moved to another position b. So, now the distance travelled is x2. Speed of the body is distance travelled x2 minus x1 over time taken. Time taken is t dash minus t. We can write it as delta x over delta t. Now, when we talk about velocity, the same object is moving from origin to A and then to B. The same definition can be used for velocity also, because the motion is in one dimension. In one dimension, arrowhead or the direction of displacement is from A to B. Always we are considering this to be positive in all the cases. Now, in case the body travels backwards, in that case velocity and speed will not be the same thing. So, speed we can say speed is equal to magnitude of the velocity when the body is moving in a straight line in the same direction, in a particular direction only, not in any direction, then magnitude is same. Otherwise, magnitude of speed is always greater than velocity, magnitude of velocity. Now, we define uniform velocity. Uniform velocity is if we have equal displacements are covered in equal times, however small the time may be. Any small time we take, distances travelled should be same. Say we have an object, this object is travelling in a straight line, it is travelling 1 kilometer, 60 kilometer in 1 hour, 60 kilometer in the next hour. We may tend to have a tendency to call it uniform motion, but this is not uniform motion. If this will become uniform motion only if we take, let us say, 1 minute, then the distance travelled should be 1 kilometer. Similarly, in any other time of 1 meter, distance travelled should be 1 kilometer. For 1 second, distance travelled should be 1 by 60 kilometer. So, only then, and if this velocity will be uniform only if the direction of motion is same. If the direction of motion changes, even then velocity will not be uniform. So, to have uniform velocity, we say velocity is constant. Magnitude of velocity is same, direction is also same. If the velocity is not uniform, the motion under uniform velocity is uniform motion. If velocity is not constant, velocity is not uniform, we call this velocity as variable velocity. Now, we define another term, average velocity. Average velocity is displacement, total displacement divided by the time taken. x 2 minus x 1 over t 2 minus t 1. When the motions are recorded at time t 1, x 1 is at t 1 and x 2 at t 2. So, this is delta x over delta t. Now, if the velocity is constant, v is constant and displacement is x 2 minus x 1 in time t 1 to t 2, we can write v is equal to x 2 minus x 1 divided by t 2 minus t 1. Graphically, we can represent this now v is constant. So, we can write x 2 minus x 1 is equal to v into t 2 minus t 1, or x 2 is equal to x 1 plus v into t 2 minus t 1. If we take x 2 equal to x 1 equal to x 0, displacement at x 0 time, we can write this as x 0 plus v, and t 2 we take as t 1 as 0, we can write this as v t. X is equal to v t plus x naught. Now, this equation x is equal to v t plus x naught. This equation, if we compare this equation with the equation of a straight line, we find the two equations are equations of a straight line. Both the equations are equations of straight line. So, if we plot a graph between x and t, we will find the graph is a straight line. It starts from x naught, this is displacement or x along y axis, and t time along x axis. Time is independent variable. We can write at t 1 displacement is x 1, at t 2 displacement is x 2. In this triangle we have from A to B, this is time t 2 minus t 1, from B to C it is displacement x 2 minus x 1. Now, velocity we have defined as x 2 minus x 1. If we write this in this triangle, if this angle is theta, angle CAB is theta, in this triangle x 2 over x 2 minus x 1 over t 2 minus t 1 is equal to tan theta. So, we have tan theta is slope of this line is displacement time graph. So, this is slope of displacement time graph. So, velocity in the case of a uniform motion is equal to slope of the displacement time graph. Now, we come back to this equation. In this equation, we rewrite it x minus x naught is equal to v t. X minus x naught is equal to the distance travelled, distance covered. This is equal to v t. This equation S is equal to v t is the equation of uniform motion. So, this is the equation that we will be using in our numerical problems on uniform motion. Now, if we have uniform velocity or uniform motion, velocity is constant, v is constant. If we plot a graph between v and t, velocity is constant. So, it will remain the same, it will have the same value, it will remain the same at all times to come. So, the velocity time graph for a uniform motion is a line, straight line, a line parallel to the time axis. So, v t velocity time graph for uniform motion is a straight line parallel to time axis. Now, when we have plotted this velocity time graph, let us say we have this time t1, another time t2. Now, area of this graph, area A, B, C, D is equal to AB into BC. What is AB? AB is T2 minus T1. What is BC? BC is V, velocity. So, this is V into T2 minus T1. What is this? This is equal to x2 minus x1. Now, what is x2 minus x1? x2 minus x1 is displacement. Displacement x2 minus x1 is equal to area ABCD, area of velocity time graph. So, if we are given a velocity time graph, we can find the displacement. Now, with this we have discussed all the terms related to uniform motion. In the next lecture, we will extend this discussion to non-uniform motion, variable motion, motion with variable velocity, or what we call accelerated motion. Thank you.